happening. Ear sound is coming from the background, you mean to say?
Yeah, from your background. That's why I'm going on mute again and again.
There is no air.
No, now not the air, but background sound is there.
Is it better or it is still there?
It's okay. Now it's not there.
Okay. Probably I need to change these earphones. Okay. So now let me just go here and talk about process switching. So what happened in the process switching? Processor would directly involve whenever any packets arrived. Okay. And this process switching is available on each hardware platform. Okay. And this process switching basically nowadays used in the debugging. So when you are doing the debugging, so at that time you can use the process switching. So I would say, let's say this is my switch which want to transfer the packet from this system to this system. So what happened when you transfer this the packet over here from this system to this system? What usually happen? Okay, so let's say this system want to transfer packet to this system, which is having this IP 192.168.2.3, and this system has a MAC address as well, AABBCC something. This is the MAC address, and for this one, this is having the MAC address BBCCDD something. This is the MAC address. So whenever this want to transfer the packet from this system to this system, what happened? When this would send the packet, IP packet. So IP packet would be like this: source IP address, destination IP address would be on the packet. Okay, source IP and destination IP would be on the packet. Also, this system is knowing its MAC address, so there would be source MAC address and destination MAC address. So for switch, it would be like a frame. So whenever this system try to transfer the packet, first of all, switch is going to do the ARP resolution, ARP. Okay, it would be knowing, it would be doing the broadcast that who is having this IP based on the ARP. And once it learned the ARP, it is going to record that ARP over here. So in all these process, what is involved? Basically, processor is going to involve directly with each packet, because if processor would not be involving over here, ARP resolution would not happen. Okay, so this is known as a process switching, where processor is involved with each packet, and this is really very slow because a processor has to look the packet from all the beginning parameter. When I say all the beginning parameter, that means IP address, MAC address, okay, all those things it has to look. So this process switching is really important when you are doing a debugging. Okay, if there is any issue in the packet and if you want to do the final debug, then you can use the process switching. But nowadays, the time has been changed, and nowadays communication required really fast. So we are using another type of switching mechanism, which is known as a CEF, Cisco Express Forwarding. Cisco Express Forwarding basically. So I can give you example and comparison as well. Let's say you have a network. Before understanding the CEF, I'm just going to give you example. So let's say you have this switch, and let's say this is a multi-layer switch. This is a multi-layer switch. which is learning a network, a different network from different router. You have 3 router is connected. And from 3 router, this switch is learning a different network. So let's say from here it is learning 10.0.0.0/8 network. It is learning from here, and from here it is learning 192.168.0.0/24 network, and maybe from here it is learning 172.16.0.0 slash let's say 16. So 3 network is being learned from this particular switch from different place. Okay, and now let's say there is a machine which is trying to send the data. This is the machine, and this machine got some IP. Let's say this machine having the IP, let's say 193.1.2.3. This is the IP, and it's trying to send the data to this destination. What would happen? Can you guess?
This is the first time where 193.123 is trying to go on 10 network, right?
Right.
Okay, so first this PC 193 will go to what do you say, for that IP address to the multi-layer switch where source and destination IP address. After that, source MAC address will be there. Destination MAC address will be FFF for the broadcast. And then multi-layer switch will verify this IP is not on this thing, what is it, on the same subnet. So it will go look in the routing table and forward to the next what do you say, next router or to the next path to get the to reach to the destination.
Correct. This is what happening. So basically on switch, there would be routing table, which is kind of known as a RIB, routing information base.
Okay.
So kind of routing table would be here on the switch, right? And whenever the traffic is coming, this is going to check whether this destination is where it is. So
Destination
it
IP
is where
address.
it is, let's say this over here. Okay, so it would try to resolve the MAC address of this, and it would do the handshake based on the MAC address, and it is going to take the time, right?
Yes.
Why? Because it has to do layer 2 lookup and layer 3 lookup, both it required.
Correct.
Okay, layer 2 for understanding the MAC address of this interface so that it can transfer the packet, and layer 3 is required. Only the MAC address is not enough. It should know the next hop. What is the next hop? Okay, so layer 3 lookup is required. So this is going to take a lot of time. We have another mechanism which is known as a Cisco explicit forwarding. What happened in Cisco explicit forwarding? Let's understand via this one. This is going to reduce the time. This is reducing the time of your switching forwarding basically. So here, what is happening basically? The benefit of SEF would be less CPU intensive than older switching mechanism. Older switching mechanism is what? Process switching. So it's very good in terms of here it is going to avoid the process switching. Okay, and it forward the traffic based on SEF table and adjacency table. There are 2 tables it is going to create, and based on that it is going to forward the traffic. So I would say that how SIF is working, let's understand via this diagram. So let's understand via this diagram that how SIF is working. Okay, let me just Okay. So let's say we have same thing. We have a multi-layer switch or switch. Same thing we have multi-layer switch, but this time instead of using, process switching, we are using safe. What happened? What happened in safe basically? Whenever you connect all these router, as soon as you connect all these router, the safe is going to create one table which is known as the adjacency table. There would be adjacency table. Okay, so it is going to create adjacency table. And in adjacency table, what it is going to put? It is going to put whatever directly connected neighbor would be. So all the IP it is going to put to adjacency table. So for example, let's say this is the neighbor router and this got IP 10.0.0.2. Okay, and it would be connected to F0/0. So what it is going to do, it is going to put that there is a router 10.0.0.2. It is connected to F0/2. That's what it is creating. There is another, sorry, 0/0 it is. There is another, maybe this neighbor. So this neighbor would be having this IP 192.168. dot, let's say 1.2, and this is connected to F0/1. So it is putting over here that there is another router is connected directly to this, which is 192.168.1.2, and it is connected to F0/1. And then we have F0/2. Okay, so let's say this router has the IP 172.16.1.1. Okay, so it is going to put 172.16.1.1 and it is connected to F0/2. So this is the adjacency table. In adjacency table, it would putting the information about the adjacent router. I mean, you can see it is kind of neighbor router, right? So it is the putting the information about the neighbor router, that which all the neighbor devices connected. Okay, this is the one table, and there is another table it is going to create, which is known as a fib table. This is adjacency table, and there would be another table as well, which is a fib table. What is the full form of fib? Forwarding information way. Yeah. So this is fib table. What would be in the fib table? Basically, best routes would be on the fib table. So for example, in fib table, this would be putting that this 10.0.0.0, 10.0.0.0, for 10.0.0 next hop, this is the destination, and the next hop. What would be the next hop for this? So it is putting that for 10.0.0.0, what is the next hop? The next hop is 10.0.0.2. Okay, how this fib table is going to create? The fib table, it is going to take the routes from rib only, and best route it is putting for the over here. So you might have a different types of route. Maybe for one destination there could be two routes, or for one network there could be two routes, but whatever the best route would be, so from rib it is going to put into the fib the best route. There is another network 192.168.0.0, this network. So for this network, what is the next hop? So it is going to put that next hop is this 192.168.1.2. This is the next hop. And there is another network 172.16.0.0. And for this network, what is the best hop? 172.16.1.1. So that best route would come from the rib and going to put over here in the fib. Now what happened if someone is sending the packet from this system to here? How this is happening? So it would look the source, that what is the, when the packet would go over here in the switch, it is going to look the source. What is the source? It got, this is the source. What is the destination? This destination. Okay. To reach to this destination, what is my next hop? This is the next hop. It is going to look that this is the next hop. And next hop, it is learning from where? It is learning from F0/0. So what it is going to do? Immediately, by seeing the next hop, it is going to transfer that traffic on F0/0 from this interface. It is going to send the traffic. It do not need to do any kind of layer 2 lookup or layer 3 lookup, because all the information is ready made over here. So as soon as packet is coming from this system to this network, the packet would go to the switch, and switch is immediately going to check what is the destination. The destination belongs to 10 network. Okay, what is the next hop? This next hop, from where it is learning? It is learning from F0/0. That means the traffic need to send on this interface, and rest of things it is going to take care. You can see very fast this would happen very fast, because now it do not need to do any kind of layer 2 lookup, because as soon as these devices going to get connected, and as soon as your rib is going to be created, your fib and adjacency table would be created in advance. Okay, it's not in the time of when packet come and switching would happen. No, it would be created in advance, fib table and adjacency table. So immediately whenever any packet is coming, it is going to look that destination. What is the destination? Based on the destination, it is going to transfer the packet to a particular interface. Let's say destination this time is 172. What happened? It would go to switch, right? And further switch. No, for this 172, what is the next hop? This next hop. From where this next hop is learning? F0/2. So packet need to send on this interface. Immediately it is going to choose. Send. So you can see here how the checking and happening, and how the packet is processing. It is very fast. That's how the Ceph work. So you can see here. These are the routes it is learning. These are the routes, different types of route. Okay. From where it is learning, what is the next hop? Next hop you can see here. Next hop is directly attached. Next hop is received from somewhere, or next hop having some IP. And this is the adjacency table. You can see this is the adjacency router. So there is one router is connected, and which is sending all these kind of destination. So Ceph having the adjacency table, and Ceph has the fib, forwarding information base. Okay, forwarding information base is a similar to routing table. Okay, where the best path is going to be labeled. Best path is going to picked up, and processor would not involve on this, on the route lookup. What is going to involve? Only the table. Okay, it is learning the routes from the table, and it is sending in that way. So this is really very good Cisco explicit forwarding. I would show you in the practically this Ceph when we are going to learn switching. But as of now, just got the concept that this is the Ceph, which is having two types of routes. One is fib table and rib table. The difference between fib table and rib table: on fib table, the best path would be selected as a next hop. Okay, but in the rib table, routing information base, your switching sorry, your processor would be involved in terms of uh, deciding the best path.
RIB is nothing but the routing table, right? Show IP
Right,
route.
routing information base, right?
Okay. And this FIB, fib table, uh, FIB is collecting the data, or I must say the routing information from RIB,
Yes.
or FIB is giving information to RIB.
No, RIB, FIB is collecting the information from RIB.
Okay, okay. And just keeping that data with FIB, and in case if any route fails in the RIB, so FIB can give the information, the next available path, or how it is.
No, no, no. Because the main source for learning the routes is what? RIB. So if there is any routes fail in the RIB is going to be updated. And as per update, fib is also going to be changed.
Okay.
Yeah. So FIB you can sorry, RIB you can see this is the master database. If there is any changes on the RIB, so FIB is going to also change.
The secondary master we are maintaining in FIB.
Yes, yes.
But if RIB is sufficient to route the traffic and all, why we need the FIB unnecessary?
Basically, for fast switching, we just want to do the fast switching. That's why we just, because if you are using Ceph, so Ceph is sending the data on what? Ceph is not sending the data based on the, layer 2 lookup. It is sending the data based on the, it is sending the data based on the adjacency table and the fib table, because it is going to know that this 5 network having this next hop, and it is connected to this network. This is learning from here, okay, from this interface. So that means if any traffic for this destination going, so what it is going to do, it is going to look into this their fib table, and based on the fib table, it is going to send that packet to this interface. You got my point? So it is not going to look to actually destination is reachable or not. It is going to immediately send that packet to that particular interface.
On the basis of RIB information.
On the basis of, yeah, RIB or fib information, you can say.
But yeah, that's what, like, why we need FIB, because RIB is having the information and FIB is taking information from RIB only. And if any route fails, RIB updates its database to reach to the destination, and FIB is again collecting the information and keeping in FIB without any reason.
So if you see in my previous explanation where I told you that the RIB is basically, it is going to do layer 3 and layer 2 lookup. Okay.
Correct.
So when the lookup would happen for layer 2 and layer 3, it is going to take the time. Okay. So to avoid that time, basically there is another table is created, which is fib. And basically this table is saying that particular destination would be reachable via which interface. So instead of looking layer 2 and getting the information about that, whether that interface is up or not, or what would be the actual interface for the sending to the data, fib would already collected those kind of information with the help of adjacency table. And whenever the any packet come, instead of looking the interface information, it is going to immediately send that packet to the destination via a particular interface. So as if I say in this way, let's say there is a system which is trying to send the data based on the RIB information. So what happened in RIB information, basically, it is knowing that this destination, XYZ destination, next hop is this one, but it doesn't know that this next hop, where it would be. It would be on R1 or R2 or R3 router. The destination, it doesn't know that next hop is what. Let's say next hop is 10 dot 1.1.2. But whether this next hop is on R1, R2, or R3, okay, it doesn't know. So what it is going to do, first of all, it would know that where this next hop is located. So it is going to layer 2 lookup and going to get this next hop information. So it got information that let's say next hop is on R2. So when it is trying to get that information, this is time consuming. But what if you have fib? In fib, what happened? Whatever the next hop have, all the next hop information would be here, that this next hop is connected to X interface, Y interface, or Z interface, let's say. So let's say this is the destination 10.0.0.0, and this is F0/0. So this fib is going to maintain the table. This is fib table, forwarding information base table. In forwarding information base table, it is going to tell the destination is this one, next hop is this one, let's say 10.0.0.1. okay, and this next hop is learning from where? It's learning from F0/0. So immediately layer 2 lookup would not happen over here. Whenever any packet comes, okay, so that packet it is just going to send on this F0/0, and it's this router responsibility to forward that traffic to actual destination. That's why it is going to maintain another one with the next hop. Sorry, with the destination router, next hop, and interface through that data should be transferred. So all that information would be on the fib table. It is not possible on the RIP table. On RIP table, there would be information about destination routes, next hop, but not layer 2 information. So layer 2 information would be also here on the fib table.
That means FIB table is helping the RIB table to reach to the destination.
Correct. And FIB table is going to add one more parameter so that layer 2 lookup would not be happen. That means process switching get avoided.
Okay. So this means RIB table is taking data from the FIB table also. It's not like
No,
only
sorry,
FIB table.
FIB table is taking the data from RIB because best route, where would be the best route? Best
RIB.
route would be on RIB, right?
Correct.
And if you see in this safe table, which is fib table, what it is, these are the destination. These are the best route. Okay. So let's say this is one of the best route, 5.5.5.5, and this is the next hop is this IP. From where this is learning? This information is coming from where? On the RIB table. There would be RIB table on which this information would be presented. Okay. And from there it is getting this information. You got my point? Or is still confusion?
Still confusion. Can we take a break for a minute?
Yeah, sure.
Yeah, thank you. Okay, Amar.
Okay, you back?
Yeah, yeah. My
Okay.
confusion is we
Uh-huh.
have two tables here. One is RIB, one is
Mm-hmm.
FIB. You
Mm-hmm.
said RIB is the routing information. So obviously the best route to reach the destination which is available at present. Only
Mm-hmm.
that information will be there. Remaining
Mm-hmm.
another best route, second best route will not be there in the RIB information. Am I correct?
Mm-hmm. Right.
Okay.
Let me just explain again, okay? And maybe you can just let me know if you are not able to pick this. So
Again, one more question is like the
mhm,
same question. My question
mhm.
is why we need two tables here. One is RIB, one is FIB. If we are
That's
FIB
why
is getting
that's
information
what
from
I'm telling
RIB.
you.
Yeah.
Yeah. Let's say this is my router R1 and this is R2, R3, R4. Okay. There may be other router which is further connected to this. So I'm putting two more router over here. Let's say this is R5 and this is R6. And they are connected with different, you know, just a moment, let me just write over here. I would create a both table over here, fib and rib table both.
Okay. And if you do it is the same thing lab in the packet tracer, will we get this table which we are talking about
Yeah,
or the GNS3?
yes, right. Let me just do this.
And Ceph, we can do it only on switch or on the router also.
You can do on the router as well.
Oh. And on the firewall also.
Not on the firewall, just switch and router. Cisco switches and router. This is Cisco feature only.
Okay. But we have that Cisco firewall, Cisco ASA firewall. We can't do on that thing also.
No, Cisco SA you can't do. Let's say you have this kind of network. Sorry, not this. I would say instead of 10, let's say you have 172.16.0.0/24. Okay. So let me just create a rib table first, which is on R1. I'm creating the rib table on R1 for R1 itself. So on rib table, we would have this information. Network, next hop. Network, let's say I'm telling network over here 10.0.0.0/16. The next hop, this is 10.1.1.1. There is another network which is 10.2.0.0/16. It is coming from 10.2.1.1. And let's say there are other network which is 192.168.1.0/24. It is coming from where? 10.3.1.1. And there is another network 172.16.0.0/24. It is coming from same 10.3.1.1. This is what? This is a rib table.
On the rib table, the 10.000.16, it will be 10.1.0.0, right? For the first one.
This one, right. This is 10.1.0.0.
Okay.
This is the rib table.
Okay.
I'm telling you problem. Let's say this PC want to send the traffic over here. The traffic go to R1.
Correct.
Sorry. What are R1 going to do? R1 is going to check its rib table. It found that on rib table, if this want to go to this network, the next hop is 10.1.1. So for this 10.1.1, this R1 doesn't know that this is located whether this is connected to F0/0, F0/1, or F0/2. So it would start doing L2 lookup. Okay, it is going to do ARP resolution. Okay, and during this ARP resolution, it is going to take the time because it would send the ARP and then it would receive the ARP, and then finally it would be able to know that this is learning from where, this is learning from F0/0, and then further it is transferring the traffic over here. So to avoid this, because as soon as L2 lookup would happen, it start process switching. So what we have SAFE, Cisco explicit forwarding. As you enable SAFE is going to create two tables. One table is adjacency table. So it's going to create adjacency table. Let me write over here. Adjacency table. What it is going to put into the adjacency table? So it is going to put that if the traffic is, it is going to put all these things. That 10 dot, adjacent router. This is adjacent router. So 10.1.1.1 connected to which interface? F0/0 interface. 10.2.1.1 connected to which interface? F0/1 interface. And 10.3.1.1 connected to which interface? F0/2 interface. This is the adjacency table. Now it is going to create pip table. there would be fib table also. So let me just write our fib table. This is the fib table. In fib table, what it is going to do? It is going to put three things: the network, next hop, and interface as well. Okay. So there would be, it is going to put the information, network information in fib table. So network information it is getting from where? From RIB. All network information it is going to get from RIB. 10.1.0.0 slash 16, let's say. What is the next hop? Next hop information it is again going to get from the RIB only. So next hop it is going to put 10.1.1.1. And to reach to next hop, what is the interface it should use? So that information it get from here. So that information it is going to put over here, interface information, F0/0. So one more information is here, additional information. Now let's say if traffic is coming from this system to this network. Okay. Router is not going to look its RIB table. Router is going to look its fib table. On fib table, it would find that that destination next hop is 10.1.1. 10.1.1. What is the next interface for this one? F0/0. So it is going to immediately send the traffic to this F0/0 interface instead of doing layer 2 lookup. So that's information it is going to get. How it is getting this information? With the help of adjacency table. That interface information it is getting from adjacency table, because it know that for this next hop, this is the interface. Got my point? So in the fib, there would be additional information about the path, about the interface that would use for the next hop.
Okay.
Clear?
So FIB is the combination of RIB table as well as adjacency table.
Correct.
Which is making router's life easy to just forward the traffic without doing any L2 ARP or process switching.
Correct.
Now, in this case, router 1 will not look into the RIB instead of FIB, and on the basis of FIB, it will process. It will just forward the traffic. Router will not look in the RIB, but in the FIB. Router is looking the FIB table.
Correct.
Over here. Okay, okay. And in case if router any path goes down or something like that, so RIB will route information base will update his database. The same information will FIB will take from there, and then whatever the updates are there, so as per the adjacency table, it will verify and collect the interface also, which interface is going to there, and it will update himself. FIB update
Correct.
himself.
Correct.
Okay. But is this correct? The router is looking in the FIB table and forwarding the packet instead of the RIB?
Correct. If you have SEF enabled, so definitely it is going to look fib table.
Okay.
Okay. And through fib table, this is transmitting the traffic.
Okay. Okay.
Okay. But RIB would be always there. RIB would always there whenever,
yes.
Yeah, if let's say fib fail, so this is the second priority. If fib fail, then it is going to look to RIB, else not.
Okay. But one more thing, we saw the thing process switching and then CEF, Cisco Express Forwarding. But in between this, we have one more thing. What do you say? Fast switching kind of thing.
Correct.
What is that?
We'll see further about the fast switching, right? I mean, in next classes, we are going to look fast switching as well. Okay. Now let's understand the other thing, which is CAM table, which is content addressable memory. So basically what it is going to store, it is used in the layer 2 switching. Okay. And Yeah, it's going to use layer 2 switching, and further it is going to store the MAC addresses over here. Okay, the source MAC address would be recorded in the CAM table. This is used to determine the ports for the frame delivery. That means if there is a frame coming to the switch, okay, where that frame should be delivered, for that it would be using the MAC address. Basically, our resolution is happening against a particular destination. I can say you in this way. Let's say this is my switch, and in this switch, two devices connected, this device and this device. So basically, for both device, switch is going to maintain MAC table. This is a MAC table, and it is going to say, let's say this is connected to F0/0. So what MAC it is learning from F0/0 and what MAC it is learning on F0/1, those records would be on this MAC table. So whenever any frame is coming, okay, frame is what? The traffic, data traffic. So whenever any frame is coming, it is going to look source MAC address and destination MAC address, and it is going to see that destination MAC address is available on which port. So it is going to forward to particular port. So let's say this having AA MAC address and this is having the BB MAC address. So if this A want to send data to the B, so what would happening? It is sending the data to the switch. Switch is going to look that AA it is learning from F0/0 and BB it is learning from F0/1. So let's deliver the traffic to this destination F0/1. That's what the MAC address. So with the MAC address, what it is going to record? It is going to record the port number, source MAC address, and when that MAC address it learns, that time stamp as well. This entry would having the some expiry time. So usually 5 minutes, 300 seconds. Okay. So if there is no frame received further from a particular port, so whatever the learn MAC address, it is going to, stale those MAC address after 5 minutes. And we can run this command to know the MAC address aging. Sorry, to set the MAC address aging. So that's the CAM memory. This MAC table would be stored where? In the CAM memory. This CAM memory. Clear?
Yep.
But we have another type of memory, which is TCAM. So if you have a QS packet or ACL, etc. Okay. So where this is going to store QS kind of QS policy, okay, or ACL policy, where it is going to store, it is going to store in the TCAM memory. This is ternary content addressable memory. Some of layer 2 switches have this. Usually you would see on the layer 3 switches, okay, which is multi-layer switches or TCAM, because mostly you would be creating ACL, etc. on those layer 3 switches. QS you are going to apply on the layer 3 switches. So it is going to store ACL and QS settings. Okay. So this QS is going to return 3 values. One is true, other is a false, and third is a do not care. True means if traffic match, then that's a true. If traffic do not match, that's a false. Okay. And sometimes traffic need to be avoided, so that is do not care. Okay. So if you want to avoid the traffic, that's come under do not care. TAM uses 3 value: VMR, value, mask, and result. Okay. So you can see this is the MAC address table. Okay. If you run the command show MAC address table, this is the MAC address table. And if you want to see the TCAM, so you can run this command show platform TCAM utilization. So this is going to show you TCAM table. This In this TCAM, you can allow to, you can perform three things. One is permit, other is deny, or you can do QS policing. So QS policing is what? If you want to limit the traffic or prioritize the traffic, if you want to limit or prioritize the traffic, so you can use the QS policy. So this is a TCAM. TCAM is used for QS and ACL.
The
Clear?
returns, there are three values you said: true, false, do not care. This is for
Mhm.
you said for cost, right?
No, this is a matching criteria.
Matching criteria for what? Cost.
Yeah, if you define anything, so suppose in ACL you define something that XY traffic should match. So that's
Mm-hmm.
a true.
Okay.
If that is not going to match, that's a false.
Okay.
Yes, for QS, right, you are right. I didn't understand. Quality of services. Yes, that's what do not care. Whether particular traffic should be care or not, that's for QS.
Okay. Okay.
Yeah. Now I'm moving to fib and rib. This is the difference. Forwarding information base, IP forwarding table or SEP table, this is called. IP destination prefix based switching decision would be taken by this fib. Used in Cisco explicit forwarding. Okay, fib capacity can be dictate forwarding efficiency. So if we have long fib table, so definitely its forwarding efficiency is very good. And modern ASIC, basically application specific integrated circuit, provide the line speed. Line speed means wire speed, it is providing the speed. Okay, so wire speed means, let's say this is the wire, and if you want to transfer the traffic from here to here, there is nothing in between. No, no processor would be involved, nothing. You would be getting the speed, at least wire speed. So if this wire speed is, let's 100 mbps, so you would be getting 100 mbps speed without any delay. Okay, so that's what it is saying, that if you are using fib, so the speed of delivering the packet from one source to another destination, you are getting almost wire speed. That means no processor, no switching would be involved here. Whenever packet would be placed on this wire, it is going smoothly to another end. Okay, if you see this rib table, routing information base. So what routing information does basically, from BGP, EIGRP or OSPF, best path is going into the rib table, and from rib, the best path is going on where? On the fib table. Okay, so that's a routing information base. I mean, best path, the best path would be on the routing information base table. That's a IP routing table. And what it is going to learn? What kind of route it is going to learn? Rib, any dynamic route, static route, or directly connected route. All those routes would be on the rib table, and from rib itself, fib is getting those routes.
The same which we discussed.
Yeah,
Unreachable
earlier.
routes will be removed and updated the RIP table. And over
Yes,
here, what it says, whatever protocol we are using, either BGP, OSPF, VIGP, XYZ, it will the best route will go to the RIB.
correct.
Yeah, and RIB information, as you mentioned, will going to the FIB. And
Correct.
FIB will have the RIB consisting of two tables, RIB as well as the adjacency.
Yeah, FIB
Adjacency.
we're getting two data from
Hmm.
RIB and adjacency table.
Hmm. Okay.
Yeah,
And the router will take help of FIB to forward the packets.
correct.
Okay.
Okay, so that's what it was. Now let's go to last one, which is virtualization. Okay, let me just write over here. So let's talk about virtualization. Okay, so what is the virtualization basically? How virtualization concept came in the market? I would give you simple terms. For example, what happened in the virtualization theory? How scientists thought the virtualization? Basically, virtualization is nothing but using the physical infrastructure, you are creating a virtual infrastructure. So let's say this is what, this is your CPU cabinet. Okay, simple CPU cabinet. In this CPU cabinet, we have motherboard, we have RAM, we have processor, we have disk, LAN card, all these things we have. Okay, so you know that when you see the system performance, if you just want to see the system performance using task manager, the task manager in my system, I'm not able to see. So if you want to see the system performance, you would always see the system performance, the RAM utilization around 6% in your system, CPU processor utilization would be around 1 or 2%, disk utilization is around, let's say, 10%, LAN card is utilization around 2 to 5%. Usually you would see the system utilization in this way. Okay, so if your system utilization is really very less, okay, how you can utilize this processor 100%, disk up to 100%, and LAN up to 100%, or maybe 90% or 60%? Because other, if you're utilizing your processor 1 to 10%, let's say, so 90% of resource is wastage. Okay, so what scientists thought, why not go with the virtualization, create a virtual infrastructure? So this is the physical infrastructure, infra. So they try to do the virtualization. So what they did on the top of this hardware, they put one layer which is known as a hypervisor. This hypervisor is doing what? This is doing a virtualization. So using this hypervisor, you can create a similar machine, a virtual machine, which is known as a VM. And on this VM, you would see that CPU, virtual CPU, virtual RAM you are going to see over here, virtual disk you are going to see over here, and virtual LAN card you are going to see over here. All those things would be virtual. Even though if you have any drive, CD drive or DVD drive, you are going to see the virtual over here. So on the top of this hypervisor, it's your choice. You can create more VMs, virtual machine. Okay, so this is kind of virtualization. So what is the virtualization? Using the physical infrastructure, creating a similar infrastructure, but that is on the top of physical infrastructure. That's a virtualization. So this, on this VM, what you can do, you can install the operating system. On the top of operating system, you can install the application. All those things you can do. That's what the virtualization. And you would see the virtualization is now everywhere. Okay, you can see virtual machine, you can see virtual router, you can see virtual switches. All those things you would see virtual.